Welcome, my beautiful students. Thank you for joining me for this interactive recap and revision exercise that's based on the lesson and the webinar that we did on process capability a while back. So this recap and revision exercise focused on the very same data that we used when we did the webinar, and it's also your homework. So the homework question asks, examine the cat kibbles data set and focus on the 2014 120 gram citrate data and the SOP specification limits. And I know that all of you are aware of this data set. We've used this data set throughout the semester from the beginning. And you've also used it for your exam, your midterm exam. If you haven't downloaded it yet, I would like to ask you to download it now, because we are going to be doing calculations, or you're going to be needing it to do calculations as you continue this interactive exercise with me. Now, as always, you know that whenever we do any statistical techniques, I've always advised all my students to draw the distribution to give you an idea, a visual idea of what is going on. It is sometimes easier, in most cases I think it's easier if you actually draw that distribution, you draw that bell curve and you indicate where the spread limits are, where the specification limits are. It is sometimes easier to work with that than to work directly with the numbers. But before you can draw that, let's just quickly do a recap on the object and the box that we did in class, that activity. If you can throw your mind back and recall that activity that we did in class, where we passed around a globe and we passed around a box. In fact, we passed two around, and I asked you to try and fit the object into the box. And I asked you to then tell me your opinions, or what you found when you had to try and fit the object into the box. And I'll remind you that you told me that to fit this globe into this box, you needed to actually disassemble the globe. The globe, when you put it directly in the box, the box could not close. But when you took the globe apart and you took the stand, you took the globe, the earth ball part, and you took that off the stand, then it could easily fit in the box and you could close the box. And so the analogies that you drew, or you told me you developed from this activity, was that sometimes if you reassemble or adjust the object, then the object can fit into the box if it doesn't fit into the box immediately. And so when we later discuss this, we realize that the same applies to our processes. And the process itself would be like the object, the globe. Let's look at the globe again. So the process, the globe in this case is represented the process, and the box represented what we call specification limits. So ultimately, my beautiful students, the conclusion that we came up with after our discussions on this was that the process is the same as that object. We can manipulate the process. It is very, very rare that we can change the box or the specifications. So now that we understand a little bit more about specifications, let's focus again on the process. And let us calculate the characteristics of this particular process. And by the process, I refer to the operation that is reflected by the 2014 120 gram citrate data. And so here I'm going to ask you to do these calculations and provide your answers for that calculations. So the answer for the mean standard deviation, half of the spread, which is 3 times the standard deviation, your upper spread limit and your lower spread limit. And of course you're going to be using Excel and that cat kibbles data set to do those calculations. So now that we've done the calculations, let's look at the process, the characteristics of the process in relation to the specification limits. So the SOP specification limits was given to us in that data set. So the upper specification limit was 1280.19 and the lower specification limit is 921.73. So what can you tell me about these specification limits in relation to the spread based on the characteristics of the process that you calculated? Of course, yes, of course. Those specification limits are on either side of the spread limits. So just looking at the diagram that we drew shows us that this process is capable. However, that's not good enough. We need to really use the process capability indices to calculate and to determine what exactly is taking place. And the 3 process capability indices that we focused on in this semester is CR, which is the capability ratio. The capability ratio is also an indication of the percentage of the specification range that we use. And then there's also the CP, which is the potential performance, and CPK, which is the actual performance. And now the very interesting thing about these 3 indices is they have one thing in common, which is all the capability indices compare your specification range to the spread. Not in exactly the same way, but they all do that because that is the aim of the capability indices. They want to see if your process is capable in terms of your spread fitting into your specifications. If your object, in other words, using our analogy, if your object fits within that box. So the box is the specification, your spread is the object. So they're comparing those 3. CR requires you to divide the spread by the specification, and the spread, of course, we know from normal distribution is 6 standard deviations. It does not take the mean into consideration, but it does tell us if we multiply the answer of CR or the capability ratio by 100, it tells me the percentage of my specification range I'm using. CP, on the other hand, does the inverse of that. The rule for CR is a process is capable if it's less than 1. Rule for CP, of course, because it's the inverse of CR, is a process is capable if it is more than 1 or 1 and more. And CP, just like CR, also does not take the mean of the process into consideration. So a process, if we have a CP value of 1 or above, then we say a process is potentially capable. We don't actually know if the process is performing. So the object could possibly fit in the box, but is the object actually in the box? We don't know that unless we do CPK. With CPK, we have a look at the mean as well. And we compare the mean to the upper specification limit, and then separately we compare the mean to the lower specification limit. And then we divide that by half of the spread. The smallest value between those two is the worst state of the process. So we select only one, and we select the one that's the smallest, and that is our actual performance. The rule for CPK, just like CP, is 1 and above. So if the process is 1 or more than 1, has a CPK value of 1 or more than 1, then the process is actually performing. If you want some more detail on this, then I would like to recommend that you refer to the recording of the webinar that we did, because I gave some really good examples and a little bit more detail in that webinar video. Now I'd like us to please do these calculations. Well done, guys. Well done on doing the calculations and getting it all correct. You clearly can't ask me questions now like with the webinar, but I'd encourage you and suggest that you ask questions via the Blackboard discussion board under the process capability discussion forum in the thread for the homework. Thank you for joining me. Well done, alligators, and I'll see you in class.